Hello, my name is John Dinsley. I'm the co-owner of Charcoal House and our online business Buy Activated Charcoal. And I'm here today to discuss the topic of what is activated charcoal. People always are asking us, what is activated charcoal? Most people think of charcoal as charcoal briquettes, something that they cook food with. But we don't have time to explain that all today, but we are going to go through some basic 101 activated charcoal for you so you get a basic understanding of what it is and what it is not. Now what I have here before me is charcoal. At first you have to start with something to make activated charcoal, and we have just plain charcoal. Here's a lump of charcoal made from wood, hardwood, and in front are chips made from coconut shell, which is a very popular source of activated charcoal. In fact, it was probably the first source of activated charcoal. It was coconut char was made into activated charcoal and used in gas masks during the World Wars for absorption of poisonous gases. So that's where activated charcoal really got to start. Now both of these, even though one is wood and this was coconut, they basically, after they've been charred, they're just basically carbon. The element carbon. There is some ash content associated with it, and it can be a lot of ash content and then it's really not that effective. But in the process of activation, there's a washing process as well to eliminate this element of ash. It can be water washed, or it might be acid washed to remove things that are soluble in acid, and then again water washed to make it as pure as possible. I'm just going to set that aside for now. A few years ago, before we were involved in this business, we were visiting some people, some friends in Puerto Rico, and we had gone to see them, and we had forgotten to bring along our own spring water from the place that we were staying at. We got to our friend's house, and I didn't really want to drink their water because the city water smelled bad, tasted bad, and looked bad. My host finally said, "I can see you're thirsty. Why don't you grab a drink from the fridge?" And I said, "Oh, well, I kindly declined because of the taste of this water." And he said, No, go to the fridge. You'll see there's a beaker there, and grab some water." So I went to the fridge, opened the fridge door, and closed the fridge door because what I saw didn't look all that appealing. And he said, no, go back and pour yourself a drink. So I did. I went and opened the fridge and pulled out this pitcher and poured into a glass some gray water from this pitcher. And when I drank it, it tasted just as pure as our spring water back at the mountain. And I said, "What did you do to this?" And he said, "Well, look behind that pitcher." And I looked behind the pitcher, and there was another pitcher of water, something like this. And in that water was a piece of charcoal. Now this is bamboo charcoal. It's not activated charcoal. This was over 40 years ago. And that piece of charcoal in the water for 24 hours took out all the bad odor, all the bad flavor, and some of the other color other than charcoal, black. And the water tasted like spring water. Now that was over 40 years ago. Today we have a whole host of water filters that don't use regular charcoal. What they use is activated charcoal. And here's an example of one that we use at the house. We pour in the water in the top, and as fast as that water can flow through the activated charcoal, it takes out the chlorine, any bad flavors, any odors, and out comes pure water. And basically, it's using a cartridge similar to this one. And what I've done here is taken off the top of a used one, and we'll maybe zoom in a little later and show you, but in here is very fine activated charcoal beads. And I'm going to pour some of those out on this plate for you to take a look at. They're mixed with some polymer balls to help the water flow through. But you can see it's almost like sand. Very small, very light, very easily the water passes through that, and like magic, as it goes through, charcoal grabs onto these things and won't let them go, and what comes out the other side is pure water. Now, the charcoal in here is this product that we call GAC. Now, GAC stands for Granular Activated Charcoal. And the numbers after that, 2050, describe the range, the grade range, so that people can understand for what usage it is. So this is 2050. The S attached to that means that it's also used to remove chloramine. And we have a standard product, this one here, that removes chlorine from water and other pollutants. This charcoal is slightly larger than the one here on the plate, and this is used in kidney dialysis machines. We sell that to manufacturers. This one's a little bit smaller, and it is put into these charcoal water filters. But essentially, these are both coconut. They're just sized differently. This one is 12 by 30 in size, so it's a little bit bigger, and this one is smaller, 20 by 50. So one of the things that differentiate activated charcoals is their grading. There's the size of the grain. The largest ones typically are 4 by 8, and those are used for air filtration because the air passes through much more easily. The smaller the grain is typically used for water and liquid filtration. Now, we started off showing you that what was simply used before is just plain charcoal for filtering water. And in Korea, they actually have swizzle sticks, little bamboo swizzle sticks. They're not activated charcoal, but you get a cup with some hot water, and they'll use this little charcoal swizzle stick, and they'll swizzle that, twirl that around in the water. In a minute, all the chlorine has been sucked up by that little charcoal stick. So the simple product works. Why do we then use activated charcoal? Well, it works a lot faster. What this may do in 24 hours, this will do as fast as it pours through it. So that's the advantage of activated charcoal. They both do the same thing, but the activated charcoal does it much faster. And in our day, everything has to be fast, so it's the right thing for the right time. Now, just as these products are used for filtering water, here is another simple example of charcoal filtering air. These are carbonized bamboo sticks. They've been hollowed out somewhat, and they're decorative, and they make them into chandeliers, and they hang them around their house, and they set them on the table as decorative items, and as the air comes to it, it grabs the pollutants from the air and removes them. Now, let me just remove this out of our way. In this case, the air has to come to it. Right? Charcoal can't reach out and grab anything. So today we have activated charcoal filters, all kinds of them. Just as there are hundreds of different kinds of water filters today, maybe thousands, maybe most of them using the same product, just so there's hundreds, if not thousands, of different activated charcoal air filters or vapor filters, and they all work the same way. But somehow they have to get the air to them so that they can take those pollutants out of the air. Even the nuclear power plants have these large cribs of up to 5 to 10 tons of activated coconut charcoal to remove radioactive material before it goes up the flue and out into the atmosphere. And that's another whole discussion point. So this is the very simple form. Over here I have some granular charcoal. It's a smaller grain, but it works very effective in grabbing odors in the house, and we call it pure nonsense. Sort of a play on words here. and we put them in little sachets, and you can put them around your house, the same idea. And as the air passes over it, it grabs these pollutants out of the air and refreshes the air. Again, a simple example. Let me just move this over a bit. This is activated charcoal. You could put this on a plate, and as the air passes over it, it will also grab pollutants from the air. This is just some plain charcoal powder that we started with this, and we pounded it up and put it through a blender, made it very fine. And in hospitals in the 1800s, they would put this powder on plates, spread it around on a plate, place these plates around the hospital wards where there were infected wounds, gangrenous wounds, and this charcoal would grab these terrible odors out of the air and make it more livable for everybody as far as the odor was concerned. So here we have activated charcoal, here we have plain charcoal. Here we have plain charcoal, and here we have activated granular charcoal for odor control. Now this is a granular product. This would be the same thing that you would put in, you might see them in some restaurants or eateries where they have these, looks like a cooler on the ceiling, but actually it's a air exchanger, and they have granular charcoal in them. A little bit larger than this would be a 4x8 granular charcoal, and maybe 25 to 30 pounds of activated charcoal. And that would work probably for 3 to 6 months in an eatery or say a drinking place where there's a lot of smokers, and they call them smoke eaters because they just suck up not only the smoke but also the pollutants associated with tobacco smoke. Well, technology being what it is, we have to make it faster yet. And I was mentioning to you the powder on plates for odor control. Here is a fabric. This is actually a woven fabric that has been carbonized, activated, and it works phenomenally fast. If you think this stuff works fast, and it does, this is almost instantaneous. You have to handle it gently. Typically it's quilted between other materials so that as the air passes through it, it will not fall apart. You have to quilt it with something. We're going to show you in a bit a face mask that we sell. It weighs as much as a little dust mask, and yet that mask does everything only faster that these canister masks do that we're so accustomed to seeing for gas or at paint and body shops. Those canister masks actually have this kind of granular charcoal in them to do that job, but now these can do it even faster. So again, here you see plain charcoal and the technology that activation has gone to, where you actually, here you have something quite bulky, a lot of charcoal here. This little bit of charcoal here does everything that this would do, but much faster. That's maybe some 101 about activated charcoal as far as applications are concerned. But now let me just take a break and talk about how does it actually do that? What's the mechanism so that one can work faster than the other? The fabric that I showed to you is actually a wood fiber, and that's why they were able to carbonize it. We showed you the wood pieces, again coconut, bamboo, but it's also, activated charcoal is also made from coal for certain applications, especially in these electric generator plants. They'll use activated charcoal made from coal to be able to pull out some of those sulfides and other contaminants in the air. I mentioned to you also about that plate with the charcoal powder on it being used in hospital wards in the 1800s to capture bad odors from the air. Well, here we have ACC, activated carbon cloth wound dressings that were developed from this cloth to do the very thing that just simple charcoal was used for back in the 1800s. So here is a picture of the sleeve with a cloth, a wound dressing inside, and you just pull that out and apply it to a wound that has a very bad odor. Not only does it take care of the odor, it also neutralizes the bacteria that produces the odor, and thereby actually improving wound healing. That's why it's called advanced wound care. Well, how does this all work? Well, maybe a simple way of describing this would be to use some sponges as an example. In the world of activated charcoal, there are basically recognized 3 different pore structures. I showed you that piece of wood charcoal, and it does have an internal structure. It's sort of like a sponge, but it's very dense. Now for example, well, let's just use one of these that I showed you before. If you started off with 3 pounds of just regular charcoal, the coconut charcoal, for example, the chip, you would end up with about 1 pound of activated charcoal. You've heard the saying, less is more. Well, that is a perfect example in the world of activated charcoal. It's the same product that you start with, only less of it. So if you can imagine, you start off with a sponge that's very dense, like this one here. It's very dense, but as you put it through the activation process, which I'm going to talk about a little bit later, what happens is it begins to erode the inside of the charcoal particles while the outside basically stays the same size. The outside surface area doesn't change. It's the inside that erodes away, giving it more pores, and eventually you're left with this charcoal skeleton. So it peels away layer of carbon atoms on the inside, not so much on the outside, and you end up with more and more pore structure. And that pores, if you could somehow then unfold all that internal surface area from those pores, you could end up with, well, 1 teaspoon of activated charcoal powder has the same surface area as a football field. Now, 1 teaspoon of charcoal powder equaling a surface area of a football field, you can imagine how much it can pull to its surface and hold it there, and that's exactly what charcoal does. So we start off with something that has very small pore structure, and we call that microporous. Then we go to something with slightly larger pores, and we call that mesoporous. And then a little bit larger again, we have macroporous. And the larger the pore, the larger the molecules that it can pull into itself. If the molecule is too big, it's not going to go into a microporous charcoal. And so the industry has come up with different techniques to be able to build activated charcoals to match the certain size of molecules that they want to remove from a product. That might be in the pharmaceutical industry where they're dealing with drugs. It might be the nutraceutical industry where they're dealing with nutraceuticals, vitamins and minerals. They want to purify them. It could be vegetable oils where they want to take out rancid flavors or bad odors. It can be used, as I mentioned earlier, in air filters, water filters, taking out different things. And these are all designed partially by developing the pore structure of these different activated charcoal molecules. Okay, we've talked a little bit about the porosity of different activated charcoals. I'd like to mention just briefly the wide applications. We've talked about air and water. We have a logo for our business. It's called Purify Your World. And whether it's purifying your water to make it more appealing, or the air that you breathe. The applications from there go on and on and on. For example, most people know that aquariums will use activated charcoal in their filters to filter the water as the fish swim around in it. But here is a charcoal made from bone char, from old cows that is charred, and it has a special affinity for heavy metals in water, which the activated charcoals don't work as well for. So here's one made from bone char. Now from fish we go to, how about that, chickens. Who'd ever guess that charcoal is good for chickens? But in Europe, studies have shown that they've given chickens in livestock animals, and it really helps them with poisoning. Studies in Korea have shown that by giving just a small amount of charcoal to chickens actually increases their egg laying and the size of the eggs. I don't know how that all works, but again, part of its mystery, charcoal is able to absorb toxins in the gut that are produced by different bacteria, or maybe something that they ate, which then relieves the chicken. It takes the stress off the animal. So here's two very different applications for activated charcoal. Activated charcoal made from coconut shell is the #1 antidote for radioactive poisoning. Who would have ever guessed? We never heard that when we had that tsunami in Japan and the Fukushima nuclear reactor disaster. But in fact, it is the #1 remedy for radioactive poisoning. So there, it was used anciently by the Egyptians. Now that would not have been activated charcoal then, obviously, but they actually buried their dead in layers of sand and charcoal. Well, today, if it works so well to preserve dead people, how does it work in preserving living people? Well, it does in hospitals. It's used routinely for accidental poisoning, drug overdose, attempted suicide, to neutralize poisons or drugs that will take a person's life. As mentioned earlier, it's used in dialysis machines, liver and kidney. It's used in wound dressings, ostomy bags in hospitals, cancer of breast cancer surgery, and the list goes on and on. So the applications are as varied as the imagination. In fact, in outer space, you know, they have to drink water and they have to breathe air. But there's none up there, so they have to ship it up there. They have to blast it up on a rocket. Do you know how much this water would cost the American taxpayer to get it into space? Somewhere up to $10,000 per liter of water. Well, once you drink it, what do? Just going to throw it away when you're done with it? Oh no. They pass it through filters. That one of those filters happens to include charcoal. And whether it's the water where they drink up there or the air that they breathe, it all costs around $10,000 per liter. And so they recycle it over and over and over and over. And while none of us have been out in outer space, charcoal will be surely on those rockets that go to Mars coming up soon. Its versatility is so amazing. In fact, one of our customers is NASA, and they are doing experimental work with this charcoal fiber cloth that I showed you earlier. Well, how does this all work as far as how do they make regular charcoal into activated charcoal? Again, the principle is less is more in regular charcoal. There are basically two ways of doing that. They are steam activation and chemical activation. Steam activation usually works with coconut charcoal or coal, and they put them in these giant kilns, and these kilns rotate. And as they rotate, the material passes down through this kiln. It's heated up, but there's no air really involved. The air is excluded as much as possible, and they inject water, which instantly vaporizes into steam. This becomes an oxidizing agent that carves away the internal structure of the carbon particle. And when it comes out the other end, it's activated. When it went in, it was just plain charcoal. And when it comes out, it's activated. It's the same thing, only there's less of it that went into the kiln. Now that's a very simplification of steam activation. Now it actually has to get pretty hot in there, anywhere from 600 to 1200 degrees centigrade. Now you're not going to be able to do that in your kitchen oven. And a lot of people ask us, well, how do we make activated charcoal in our home? Technically you cannot do it because your kitchen oven is never going to achieve 1200 degrees Celsius. At most it might reach 200 degrees Celsius, but that's not enough to create this process of chewing away the internal structure of the carbon molecule. Next we have chemical activation. In this process it takes less heat and less time, and what they do is they coat this charcoal with a chemical like an acid, like in this case phosphoric acid. They use other things like potassium hydroxide or zinc chloride. But what it's doing, when you coat this charcoal with these chemicals and then add heat, but you don't need as much heat, in this case you'll need maybe 450 to 900 degrees Celsius, the heat speeds up the chemical chewing away at the internal structure of the charcoal particle, and you end up with activated charcoal. And typically it's used with wood-based charcoals, something like hardwood. Some of our products are made from, come from the hardwood sawdust or hardwood chips that are left over in the furniture factories. You know, when they're done making all their furniture and they have all this waste wood, what are they going to do with it? Burn it up? No, they char it and then activate it, and they have this activated charcoal powder that has a wonderful ability to take larger color molecules out of products. So wood charcoals are often used for that, to take color out of certain things that they don't want. I think Daniel is going to show you actually how to remove color from grape juice using a wood-based charcoal that's been chemically activated. So there's an example of chemical activation and steam activation. I've described it very simply, but you still have to have this giant kiln that can reach very high temperatures. Even 450 degrees Celsius is not something that you can achieve in your home oven. Now you have these two charcoals. They're then taken out in size. They might be crushed further into a very, very fine powder. The finer the powder does not mean it has a higher activation level. It just means that it works faster. But again, these are all designed and graded for specific applications. The two general applications are liquids such as water, and the other one is air and vapor. But it's used in the purification of gold mining and potassium and very fine chemicals. The list goes on and on and on. And one manufacturer said 1,000 applications today and 1,001 applications tomorrow. And we've certainly seen that in our business. People are constantly contacting us for a certain kind of charcoal that they want to develop a certain product for. And the list goes on and on and on and on and on. Everything from cancer of the teeth to little sachets of granular charcoal like this that are placed next to computer screens to capture a what's the word I'm looking for? Radioactive waves, not radioactive, but microwave feedback. It's used in sound systems to take out background sounds that they don't want. Again, you can see the list is very wide. And essentially, it purifies our world. And we've done a wonderful job of polluting our world. And I think God has given us something that is so amazingly simple to help us clean up a lot of the mistakes that we've made, keep our bodies healthy, our water healthy and pure. We're going to show you some products for detoxing your soil when you poison your soil with chemicals. In fact, I think it was last year, Daniel got a call from a nursery that grows one of the larger growers that turns out poinsettias for the Christmas season. And they were frantic because they had accidentally poisoned all their stock of poinsettias, and what are we going to do? And they heard about us, called us, and Daniel took the call and said, sure, we can help you. And we overnighted some soil detox to them, and the poinsettias went out for 2013, and everybody enjoyed poinsettias for Christmas. So again, you can see there's such a wide variety of charcoal, and we haven't even touched the idea of charcoal and its medicinal applications, really. I actually got started in this business by writing a book called charcoalremedies.com, and I would encourage you, if you want to learn more about the applications of charcoal and its medicinal uses, you can go to charcoalremedies.com. And it's a more information-driven site. Bioactivated Charcoal is a product-driven site. We have over 180 different charcoal products for you to look around at. We would like to have you contact us if you have questions, but we always ask first that you review our websites. There's a lot of free information there that will give you heads up on how to make simple charcoal. We'll post these videos so that you can watch them. And above that, if you have questions, you can always email us at customer support, and we will get back to you, maybe not immediately, but we will get back to you. Well, I really have enjoyed this opportunity to share this information with you, and as time goes on, we hope to make more of these videos, shorter ones, on some of our different products and make them available to our customers. And hopefully you will be able to share them with friends, those who are skeptical that actually activated charcoal can do all these wonderful different things for us. Well, thank you again for viewing this video, and we hope to see you come back to our website and see what we have there as well.